Pagaki.
I'm an idiot.
I'm a stupid
Moron.
With an ugly face and a big butt, and my butt
Smells. And I like to kiss my own
butt.
I'm an idiot.
Pagaki.
We're living on a disk, floating through space, with a tiny sun.
Hey, I'm FTFE. Welcome back to the channel that does to stupidity what a Grisbolt does to a Lambo with a minigun. Play Powerball. Play Power World. It's amazing. Hello everyone. How are you? Thank you for joining me once again. I hope you've all recovered from last night because boy, that was a doozy. And I hope you had some sleep because I have not been to sleep since we last spoke. Today we have a double feature. We have me moderating a debate between Jessie PAah of Light and Ross Perry of Real Offended, and then later on I will be debating Ross because, you know, I guess I hate myself or something. But for the first portion of tonight's entertainment, I am moderating a debate between Jessie and Ross. Hello guys, thank you for joining. Jessie, how are you?
Oh, I am well, thank you. How are you?
I am doing good, thank you very much for joining me. And Ross, thank you also for joining. Recovered from last night?
Barely. Like I had to be back on stream at 7 a.m. So I took a 4-hour nap. I got up at 7 and I've been going ever since. So I'm ready to go.
About 4 hours sleep more than me then. So, you know, we're all doing good here.
Amen. Amen. And, so, hopefully by the time the second debate comes, you know what I mean, I'll be right around level where you are, you know.
Yeah, sleeps for the week, right? Who needs that rubbish? Right, so today, for Jessie and Ross, to keep it non-dumpster fire, only one of them will be unmuted at a time. They're going to take it in turns to ask questions and answer questions. I'll allow back and forth, but only one of them will talk at a time, and I'll be controlling the mic to make sure that there's no over-talking. Jessie was on the channel recently, and when he debated, it was very civil, and I'd like to give him the opportunity to have another debate that is very civil. Everyone knows that myself can have impulse control while debating, and anyone that has seen Ross knows that he has the same. So portion 1 of tonight's entertainment will hopefully be sedate. Portion 2, who knows? Let's light the dumpster fire. Right, so what I'm going to do is I'm going to let you guys have 5 minutes to just introduce yourself and state your claim. And then we can just take it in turns asking questions. Which one of you would like to go first?
He can go first.
Okay, yeah, I was going to request that he goes first, you know, so that way I could, yeah. Thank you.
Oh, I don't care.
And by the way, I'm going to have my camera off because I did just get off stream, so I'm organizing a few of my notes, so I don't want to be doing a lot of movement. I have my camera off, but I will be listening.
Yeah, no worries. Right, so who's going first, Ross or Jessie?
He's going to go first.
Right, Jessie.
I'll go first.
Okay, right, Jessie, over to you then. 5 minutes. Introduce yourself, state your claim, and then we'll go over to Rostrum to do the same, okay?
All right. Well, I'm Jesse. I was introduced to the topic of Earth shape in December of 2018 when a real life friend of mine said one day, he says, "Hey, Jesse, you know the Earth is flat and NASA's fake." And I'm like, haha, very funny. And he's like, "No, I'm serious. Check into it." So I've been checking into it ever since. And so I ended up getting a surveyor's theodolite. I've been collecting them since then. Now I've got 11 that work. And so I've been measuring. And so my claims are that we can measure angles. Should I share my screen while I'm
Yeah, if you want to.
giving my claims?
Yep, feel free to share your screen.
All right. Which one is it here? There we go. All right. Okay, so can you kind of see that?
Yep.
Looks pretty blurry to me on the feedback, but
No, it looks perfect
Oh,
on my
well.
side.
okay, cool. All right, so my claim is that we can measure angles and distances and calculate heights. For example, you can see here I have a bubble level and a protractor, and this is just symbolic of how you measure the angle to the top of, say, a tree. Tell me when my 5 minutes is up, because I'm not running a
Yep.
clock.
Yep, well, we've got about 3.5 minutes left.
Okay, and you can see here, can I zoom this? Look at that.
Yep.
This is the basic math to it. The arctangent of the rise over the run equals the elevation angle. So the run is the distance, the rise is the height, and then the elevation angle is the slope or the grade from the point in the bottom left to the point in the right top. You probably can't see my mouse too well, but there it is. And this technique is used in surveying, in architecture, in engineering, in 3D graphics programs, and it works. This is valid trigonometry, and it's tried and true. So I took this out and I've measured the elevation angle to a number of different mountains, and my personal longest record is 105 miles to Mount Shasta from Mount Scott in Oregon. And you can see I measured a tenth of a degree below eye level, when on a flat Earth I should have measured a half a degree above eye level. So that's my claim there. I claim that when you measure from a mountain peak to another mountain peak, you find missing height that matches the globe model prediction. And I'm not the first one to do this. George Everest started in the early 1800s, and in fact Mount Everest was measured in 1868 to within a few feet of the current modern measurement using this very technique. And here's a chart of some of my measurements at different distances, plus a few measurements from contributing other people, including 2 flat earthers who bothered to measure angles. And you can see it forms a curve. One other thing I've done, gotta zoom out a little there, is I measured the elevation angle of the top of this ship as it sailed across from my left to right in a straight line, and I calculated the height difference along that path, and I found that the ship appears to be sailing on a curved surface. So that is my claims. How am I for time?
You got 90 seconds left.
Oh, cool. Okay, I've also done extensive research at my local boat launch relating to the effects of refraction near the ground, and I found that when the water is cold and the air is warmer than the water, it forms a refraction gradient that causes things to appear higher. For example, on this ship on the right here, the angle to the water line on the ship on this day is 20 feet below eye level, but on this hot, calm day, the water line to the ship is 28 feet above eye level. So I'm literally looking up at the water line on the ship, which we know is below us. So this shows that stable refraction gradients lift things, not sink them. And I also did it with a lighthouse. I bet that used up about 90 seconds.
You got 27 seconds left.
Oh, okay. So in this case, I went out on a hot, calm day and a cold, blustery day, and I leveled my scope out level in both cases. And you can see that the water line on the far shore is lifted up, but on the cold, blustery day, it's not lifted up. And also the aspect ratio of the building is correct on the cold, blustery day.
And that's your
All
time.
right.
Okay, right. Thank you for that. Right, Ross, over to you. 5 minutes to introduce yourself and state your claim.
No problem. Is it okay if I share my screen as well?
Yep. Yeah, sure. Go ahead.
All right. Just give me a quick second, guys. All right. So, as everybody knows, it's up there, right? Cool.
Yep.
All right. As everybody knows, I like to keep things as simple as possible, not to overcomplicate, so that the way the average person cannot understand what we're talking about and clearly verify what we're saying, right? So, yeah, I like that he started off with a quick story, all right? So this is my quick story, right? So I got a cell phone when I was in 7th grade, and I realized that everything was a lie, right? Grew up religious, and so I started Googling everything my parents were telling me about the Bible and all that. I was like, oh, wow, they're lying. I believed it my whole life, though. I thought it was true because they told me, but I found out they were lying, right? So then I went to college, right? And from then I learned how to do independent research, and I realized that, oh, wow, this is really just indoctrination. Most of the stuff that they say that they know for sure, they don't really know for sure, right? And so then not then, but I learned what the scientific method was, obviously, as a little kid. And when I got to college, I understood them trying to tell me that scientific proof or scientific theories come from things that don't have the scientific method in it. But I personally, I don't believe that, you know what I mean? Even though they told me that, right? In my heart of hearts, it just doesn't ring true. You know, what rings true is being able to validate things with the scientific method, right? So I have these points right here lined up. And just to be clear, right, I probably watched my first flat earth debate maybe 5-6 months ago, but probably for the last maybe 5-6 years, I've been trying to tell everybody that everything was electric. Everything was energy, everything was frequency. I had been given this information from a millionaire that was mentoring me, right? And he told me, like, look, you like science, right? All right, go dig into your science and see if I'm wrong. That's literally what he told me. So I started listening to Lawrence Krauss and all these other people who I like listening to, right? And I found out that when they were telling me only the things that they knew about for sure, it did not disagree with anything that he was saying. So really quick, my 4 points are very easy. Number one, the earth is not moving. And this is like I said, all these points are based on the scientific method, but these are not all necessarily scientific theories or scientifically verifiable, right? So number one, the earth is not moving. That is a scientific theory. That is scientifically verifiable. It is backed up by experiment. Number two, the earth is the center of the cosmos. That is not a scientific theory because it is unfalsifiable. So for you guys to say stuff like, oh, we know for a fact the sun is the center of the earth, and we know for a fact, well, that's not a scientific theory by definition because it's unfalsifiable, right? So that's number two. Number three, the surface is not curved. See, now this one is not quite a scientific theory, but based on the experiments that I have seen, right, that I can verify are true, the earth is either not curved or it's so big, right? It's a lot bigger than they told us it was, that the curve is negligible based on the test that we're doing. You know what I mean? So that's my position on that. I don't know for sure that the earth is not a globe or not curved. I just know for sure that the earth is not moving. The earth is the center of the cosmos based on all observation. This is a fact, right? And then number three, the earth is not curved based upon what we see. Although, right, there are certain experiments that could be superseded by the earth being just a much bigger globe than we see. Number four, everything is dielectricity or electric or whatever you want to call it. That's not quite a scientific theory yet. But I promise you, if you look at all current scientific theories, they are all basically slowly making their way to admitting that everything is electric or ether or whatever you want to call it. How much time do I have left?
1 minute 50.
Great. I'm glad I went through that quickly. So I have all the evidence for that. Anybody who's seen my other debates, like, I'm I'm the type of guy that does not like to talk long about science, right? Because like think about it, because that's philosophy now, right? Like I did my first degree in political science and then minor in philosophy, and then I changed my major to communication, right? So philosophy is us discussing things and then giving our opinion about it. Science is really the scientific method. Now there is philosophical science that comes on the end of that for us to figure out what's true, right? The scientific method does not only it does not necessarily tell us what is true. But as far as what is a scientific theory, it does have to follow the scientific method. If it doesn't, I'm going to challenge you on that extremely hard. You know, like just on what you showed us so far, I'm glad that you were at least able to recognize that what you're showing us is observations, right? And while those observations are evidence, don't get me wrong, I would never claim that something is not evidence, right? Even if it's not conclusive, it's evidence nonetheless, right? But evidence doesn't always just point to, to one direction unless it's conclusive, you know what I mean? So that is evidence, right? But you have to understand that that's an observation, right? So even if that is your evidence, it can't be a part of a scientific theory. There are no experiments that I have seen, right, that have proved what you're saying as far as the Earth being curved. And like I said, even if the Earth is curved, that's fine. We can talk about that. Scientifically, there are no experiments, right, or valid scientific theories that go against the fact that, number one, the Earth is not moving. Number two, the Earth is, and number two, that the Earth is the center of the cosmos. So we don't even have observations that show us that the Earth is not the center of the cosmos, right? So, I mean, if you want to concede on those 2 points, then we can go on to your third point. I mean, to your point, which is my third point, that the Earth is not curved. Then we can talk about your experiment your observations and discuss how those might be valid or invalid if you want.
And that's your time,
though. Okay. Again, last sentence. At the end of the day, then you're basically just going to be postulating that we live on a curved surface that's not moving and in the center of the cosmos. So I'm that's my time. Thank you. Forgot. Thank you guys.
Okay, right. So what we're going to do then is have a back and forth with someone asks a question, and then the other person gets a chance to answer it, and then if we're satisfied, we'll then let the other person ask a question, and we'll just go on until we feel like our brains have exploded or something, I guess. Okay, we'll let Jessie go first and ask the first question, if that's okay with you guys. Jessie, I'll give you like a minute to ask the question, and then Ross can have like 2 minutes to answer, and then if there's any clarification, we can have a little bit of back and forth, okay? So Jessie,
okay.
Over to you. Ask your first question.
All right. Ross, which is the best way to find the truth? To trust other people? To do my own research and measurements, or something else? If so, what is that?
The best way to find the truth?
Yes.
I guess it depends on. I mean, that's a pretty complicated question, because we know our eyes can deceive us. We know that railroad tracks touch in the distance. So there's a lot of. This is why the scientific method was invented, because we know that just because we make an observation, that doesn't mean that it's valid, right? So we have to take that observation, make a hypothesis, and then run some experiments to test if our if our hypothesis matches what we think we see in the observation. So I would say the best way to find the truth would be the scientific method.
Okay.
Yes.
Okay. All right. Are we happy with that question? Is that okay? Yeah. Right, Ross. Then over to you. You've got a minute to ask your question.
Okay, so I don't necessarily agree with the zenith angle argument necessarily, because there's all type of topographical issues, right, that may or may not have been taken into account, right? And I'm sure you probably don't have all those answers right now, but I don't want to assume that what you're saying is not true, right? So I'll assume that you took all the topography into account, right, and that your angle measurements are perfect, right? As I said, right, because of radio wave propagation, right, things that are done by the military, and I have like literally a list of over 100 different people that have sent radio waves, right, line of sight microwaves, right, too far. That doesn't necessarily mean that it's not curved, right? So your angle thing could be correct, and my point be correct, that because whatever distance you're measuring, the Earth really could be, like so big, right? Or like I said, we don't necessarily, me personally, I don't claim that I know the exact topography of the Earth, you know what I mean? There's a lot of different things going on in there. But like I said, I'm like, I don't understand how that necessarily by itself is conclusive evidence
right? I get it. You took an angle measurement, but I already said, like, we know train tracks up in the distance. How is that conclusive evidence by itself that the Earth is a globe?
Right. So just to clarify, your question is, how is the angle measurements conclusive evidence that the Earth is a globe? Yeah.
Right. Yeah. Right. Because I also agree that the radio wave propagation is not conclusive evidence, because there could be a few different options there. So I want to know how you think that's conclusive.
Okay, Jesse, 2 minutes.
Okay, I don't know if conclusive is the right word. If you're meaning that to take absolute proof, I mean, that's kind of extreme. But if we measure drop over distance going away from us and then right to left curve, that's two curves at two right angles. So that pretty much tells us that it's a spherical surface to me.
Or it tells us that you're standing on a curved surface, but that could be. But guess what? It could be curved and then curved back. We don't know what the topography is. Does that make sense at all?
Well, these measurements that I've gathered are from 4 states in the United States and 3 different countries. So it seems.
So was the angle the same every time?
The relationship between drop over distance and the drop in the distance
right
matched the square of the distance.
The 8 inches per mile squared.
Right.
Okay.
7 inches per mile squared, because I was doing it optically and I did not correct for refraction.
Well, how do you correct for refraction? Like, how do you know how much refraction is going to take place?
It's about 1 degree of lift per 932 miles in standard conditions.
All right, but how did they figure that out? Because that seems arbitrary.
It's been tested a number of different ways. You can calculate it from the basic laws of physics relating to gases and the masses of gases.
I'm not familiar with those. I'm familiar with the laws of physics, but not as they relate to gases and the masses of gases, right? You're saying that it basically refracts and makes things push up, right?
Yeah,
I'm not familiar with that type of refraction.
It curves the ray of light downward, which makes things appear higher, right?
I don't know if that logically follows, right? Because I understand you saying that, right? But as far as we know, what we observe, right, the refraction that takes place in the atmosphere, it lessens visibility, right, for the simple people in the crowd, right? It doesn't actually magnify things and make things that aren't there appear. Are we talking about the same thing right now?
No, that you're talking about attenuation, which reduces light, but it doesn't change the angle of it. Refraction changes the angle of it, right?
Well, I understand, but changing the angle, basically, as far as I know, what we experience is that lessening visibility. No. So why do we see the coast, the horizon move in and out sometimes? Is that refraction?
Yes.
Okay. So that's what I'm saying is it's lessening visibility, right? Because sometimes we can see further, and then refraction happens, and now we can see less.
It's
right?
changing.
That's what I mean in real time.
It's changing the coincidence point between the curve of the Earth and the curve of the light.
Well, no. You're assuming that there's a curve of the Earth. We're not talking about the curve. We're just talking about visibility right now, right? So it basically lessens what you can see. You know what I mean? Like if I'm looking at a ball, right, and there's something on the other side of the ball, and I zoom in all the way, it will never bring what's on the other side of the ball up. I'm not familiar with that. Well, what type of refraction does that?
Stable density gradient refraction. Can I share my screen?
Say it, my bad. Say it again.
Stable gradient refraction.
Stable gradient refraction. And you're saying stable gradient refraction is reported in experiment to take things that are on the other side of a surface through that type of refraction and bring them up and make them visible when they were not? Are there experiments that show this?
Yes.
I would love to see those. Please.
Okay,
please.
Can I share my screen again?
Yep, go ahead.
Okay, let's see. Share screen.
I'll allow a bit of back and forward on this topic because you're being respectful to each other. So once you guys are happy with this topic, then we'll move on and let Ross ask the next question. Or Jesse ask the next question.
This is my question.
Yeah, sorry, yeah, you're right. So once you guys are happy with this conversation being finished, we'll let Jesse ask his question. So yeah, Jesse, share your screen.
I'm trying here. It's not showing him in my share list.
Oh, maybe I'm still shared.
No. He's just not picking up the screen he needs.
Let's see. I'm trying to find where the... It's not showing me my other web browser window. That's odd. It did earlier. Oh, maybe it's still being shared. Am I sharing?
No, you're not sharing right now.
Okay. Hold on. I got a new plan. I'll get it.
No, you're good. I'm listening. Go ahead.
For some reason, Discord or Zoom won't let me. It shows me all my windows I can share, but not my other web browser window. So just give me a sec.
It might be like a different tab. I don't know. Sometimes that happens to me.
All right.
I got a plan here. It won't take long.
Everyone watching, thank you for watching. Make sure you smash that like button, share the stream with your friends if you hate them and want them to dislike you.
Okay.
We good?
Let's see if it will let me share this.
The wonders of modern technology and live entertainment.
I'm glad I'm not the only one, man. Everybody makes fun of me because I'm probably the least technologically advanced guy, and I'm always making mistakes. I got a performance microphone I'm speaking on right now.
Well, you're here connected, which is better than a lot of people, trust me.
Okay, I'm just going to go to this and see if that'll let me switch now. Because that's not what I'm looking for, but at least it was... Ah, now I got the other thing. Now
there we go.
Okay. Zoom's just being a little funky. Okay. Can you see my screen, Ross?
Yes.
Okay. So this is in a fish tank with a saltwater density gradient.
Okay.
And this is a curved aluminum strip. At this lower darker green line is a curved aluminum strip. And then this upper brighter green line is the laser beam curving.
Okay.
In the gradient.
Okay.
So this shows how a density gradient could cause light to curve in such a way that it would change the location where that ray of light touched that surface, right?
Well, all this proves is that if we're looking out at the ocean and you say that you see boats go over the horizon, that it could be curving because of the density gradient. That's all this really proves.
Okay.
If I'm understanding what you're saying this light is curving because of the density. So right, so if I look out and see an optical illusion that it looks like it's curving, then it might be this regular density gradient that you're talking about. I don't understand how you're saying that light, that there's a type of refraction that will bend light from here down all the way up so that I can see it eye level and at the perfect distance. Like, why doesn't it bend it all the way up? You know what I mean? All the way up there instead of right at my eye distance. But what you showed right now seems to be proof that when we look at, light can curve, and that will give the illusion of a curved surface even when it's not.
It does. So,
so this is not helping you. This is. I'm not sure if.
Yeah. No.
I'm telling
you.
This is like evidence that it might not be curved, but it just looks like it because light bends. If I'm not mistaken.
Okay. Let me show you this. Let me change to this one. Where did it go? There it is. All right. Do you see a different picture now?
Yes.
Okay. So, do you see this blue and white sign that says stop?
Mm-hmm.
Okay. That sign is physically above my camera. It's about 300 feet away, and it's physically a couple inches above my camera, my telescope.
Right.
All right, and yet I can see this ship's waterline over the top of this sign.
Right. This is basic perspective. Like the train's touching in the distance. It's the exact same effect. When but if you think about it, right, this is the reason why we really don't know how far things are in the galaxy, right? Because once we get to a certain optical, threshold, everything just converges. So this is more proof that what we have to rely on is the scientific method. Because let me ask you this, right? Because basically what you're saying right now is that when we look out and take deep observations, Euclidean geometry is basically out the window because we have no idea what optical illusions are going on when light bends. Isn't that basically what this is proving? That Euclidean geometry basically is not valid when we're looking at far distances. So this one thing right here, like I said, not only does it debunk all observations either way, though, I'm not saying it doesn't make the Earth flat, it doesn't make the Earth curve either way. But also when we look at things in the galaxy, unless we've been there, then we have to account for the fact that refraction is going to change Euclidean geometry.
Come back to Earth, my friend.
Come back to Earth. Come back to Earth.
So you asked me how refraction would move the horizon line, right? The distance of the horizon line, right?
Right.
And that's what I'm answering. I'm illustrating that this camera was below the top of the sign, which should have physically blocked the view of the water line of that ship, and yet I was able to see it over the top of the sign. So this is very good evidence that when you're near the water, the density gradient can lift things up and could allow us to see over a curved Earth.
Wrong, because it's not lifting anything up, because that is already there. You understand what I'm saying? What it's doing is it's bringing the sign down. Right. If it was lifting it up, then that would mean that island, right, or would have to be, or that boat would have to be on the other side where you can't see it. You can see it if the sign wasn't in the way. You understand what I'm saying? If the sign was gone, you would see it regular. So you're not bringing anything into the picture. You're shrinking the sign. That's the difference.
Except that the sign is physically higher than the straight line between myself and the ship, right?
It's higher, but it's still, the ship is still there. I'm saying when things are on the other side of the curve, they're not even there in the picture. Like you understand? So it can't move the Earth, no, but it can shrink a sign. Does that make sense? It's shrinking it. It's not bringing the ship back. The ship is in the picture if the sign wasn't there. So all you have to do is get rid of the sign, and then the boat is there. So refraction will shrink the sign so you can finally see the ship. It's not that what I'm saying is it needs to bring something back that if you took the sign away and then you wouldn't see it, and then if you zoom in you could bring it in. That's what I'm talking about, right? Imagine there's no sign and then you still can't see the ship because it's over a curve, and then you zoom in and you bring it all the way. That's different because it's not there.
Well, what if I had a hill of water where that sign was? Could I see the ship over the hill of water because refraction had shrunk the hill of water?
Refraction had shrunk. The hill of water is the horizon, though. That's the base.
Can you see my screen share? Is it still up?
Yeah, you're
listen, you're only gonna see it, right? Like if the water's blocking it because of waves, then yes, because the boat is still in the picture. You just can't see it. What I'm saying is when you claim, right, that things are on the other side of an actual curve, you can't bring something on the other side of a curve back. If something is there and there's obstruction, right? Or from a line of sight, you get what I'm saying? You're still line of sight of the boat. You're still line of sight of the boat. You can't bring things that aren't line of sight into line of sight. But you're line of sight and something is blocking it. So what do? You zoom out, right? Or you zoom in, whatever, or you zoom out in this case, and then the obstruction will shrink because you're still line of sight of the boat. All right? You're claiming that you could take things that are not line of sight and bring them back from I used to say magical refraction, but you said stable gradient refraction. That's what brings things back that are not line of sight. I'm gonna look that up because I've never heard that. But wow. I've literally never heard that. As many debates as I've heard, you feel me? And as much as I've researched this, I have not heard one person say, "Oh yeah, stable gradient refraction," because most people don't want to die on that hill. But you, my friend, are a bold man.
So, did I answer your question though?
Well, you did, but it wasn't sufficient. You did answer it, yes, but it wasn't a valid answer. And not only that, before you answered, you did concede that this wouldn't be conclusive evidence alone. Like the same thing that I said with my basically curved Earth evidence, right? This is not conclusive, right? Like I said, we can argue all day about the third one, right? Is the Earth curved or not? Because guess what? We still don't know yet. We don't know the shape of the Earth at all. I'll tell you what we do know: the Earth ain't moving, right? The Earth is not moving, and then we know that the Earth is in the center of the cosmos based on all observations. So I'm willing to concede that, yeah, like you could still be right, even though that is not necessarily conclusive evidence. You know what I mean? I don't want to fall for the fallacy. You know what I mean? Just because that's not necessarily good evidence, that doesn't mean that the Earth is not a globe still. It could be a globe, but it's just, it would have to be a stationary globe, which is kind of weird.
Okay, Jesse, are you happy with that? Do you want to move on to the next question?
Could I just respond briefly to that? Okay, I'm gonna. Okay, can you see the new screen? Sure. Yeah. Okay, looks like I'm up. All right.
Yeah.
But what if
it's still the boat one? It's still the boat one.
Yeah.
With the sign.
Is it still got the sign on it?
Yeah.
Oh.
You're showing the looking over the slide.
Okay, let me try to change this again. I thought I changed it. Oh, I see. There we go. Okay, what if? What I'm illustrating is there could
still
be
the same one. Oh right, you're changing stuff. I see.
Yeah. He's editing. Oh, no.
There could be a big hill of water right in here,
Right.
instead of a sign, and now
Right.
I'm actually seeing over. That's what I'm illustrating. See?
But what you're saying right now defies the laws of physics.
Well,
Hills of
not-
water do not exist like that randomly in the ocean.
Well, one does. It's got a radius of 3959 miles.
Allegedly.
Yeah. But let's
look,
say I'm
Take a
just
picture
saying.
of the hill. Show me a hill of water like that.
Okay, I just wanted to illustrate that. That's what I was
No,
showing with the
no,
sign.
but don't get me wrong. I do understand the point. Let me respond to that, right? Just to give you, look, I understand the point, right? And if it was a random hill of water and you zoomed out, then yes, but that would be a random hill of water, right? And it's still line of sight. It's still line of sight. So this is not, I'm saying that if it's on the other side of a curve, it's not line of sight anymore. I can't send a microwave to it. I can't flash a mirror. You know what I'm saying? I can't flash a mirror over there. If guess what? If the sign is moved, I can flash a mirror. If it's all the way on the other side of a curve, even if you move the sign, I can't flash a mirror. That's the difference. It has to be, we're talking about line of sight, okay?
Right, but what if the line of sight is not straight? Couldn't it then go around a curve if there was something causing the path of the light to
That
bend?
defies the laws of physics, sir.
It's called
Yes.
refraction. Do you deny?
Line of sight. Line of sight, line, not curve of sight. Line of sight. That you're. Don't be a science denier, all right? I don't want to accuse you of that this early, all right? But most of you guys who argue for the globe, you guys are science deniers. Like I pull up real experiments, and I'm like, and even if you pull up observations, I'm willing to wrestle around those, right? But let's not pretend like if you have an observation or something, it becomes automatically science, all right? And let's not try to change what words means, right? When we say line of sight, we mean line of sight. I know how bad you want to shift that word because it'll help your argument, but you cannot do that, all right? You cannot do that. It has to be line of sight, not curved.
Are you denying that light can curve in a density gradient?
I'm sure light can curve in a density gradient, right? But that doesn't make it now line of sight. If I'm standing right here and you're standing right there, like, what do you mean? Like, line of sight is two humans, right, who can see each other. If I'm not mistaken, I'm trying to make it as simple as possible. Two humans that can see each other. If I can never see the guy, if I can't see the guy, then that's not line of sight. You cannot bring something that's not line of sight. Whoa, maybe you can, but I would like to see that evidence. Show me that happening. Like, hey, look, he's over there. We can't see him. Now, here's this experiment where we manipulate the variables, and look, the refraction. Now he's line of sight when he wasn't. You have to show that in an experiment. Otherwise, As far as we know, that can't happen. We do agree that light can bend, though, because that's what refraction is. Because, I mean, damn near by definition, but then again, that's semantics.
Okay, so would you be able to shine a laser over an obstruction like I have on my screen share in a gradient?
I don't necessarily know the answer. I mean, based upon this, it's seeming like, yeah, possibly.
Okay, I've done it. I have done it in a fish tank in real life.
Okay. How about over the curved surface of the Earth? Have you done that?
I haven't done it with a laser over the curved surface of the Earth, but I did use...
They've been trying. They've been trying, and they can... And this is why I said this is where you do have some wiggle room, right? Because if I were you guys, this would be a good argument, right, for the line of sight thing. But then again, all that does is destroy everything because you're claiming light bends. So now we don't know how it's bending and how much. So it's kind of a bad rabbit hole to go down. But if I can send microwave propagation straight past where it should be around the curved surface, right, then that's your argument right there. Your best argument for that is what you just showed. Like, oh, well, light can curve like that. But then that's not going to work because now you're going to have to figure out, well, how do you know that that's what happened? What's the rate of curvature? How do you're going to have to bring in all these other variables that I know you don't have, you know. Well, but that is a decent argument for the radio wave propagation. But like I said, it's not an argument either way. All that does is debunk the fact that it's proven that there is a curve there. Now, I don't know why people would say that I see ships going over the horizon. That's the dumbest argument ever. You see ships. All right, we see railroad tracks touching the distance. Is that scientific evidence? That's insane that anybody ever says that in a debate. You know what I mean? We all agree refraction happens. So let's throw all observations out. All observations are out when we talk about scientific evidence. It's a scientific method, experiments. Otherwise, you just have a hypothesis or a loose theory that cannot be connected to science in any way.
So if there was a guy in a dinghy right down at the waterline on the side of this big ship, and
yes,
and he's showing a laser at me, would I have seen the laser over the top of the sign?
I guess it depends on how close you are. If you're saying from right there, you already demonstrated that you were far enough that the sign would that you would see it. So yeah, you brought him back to line of sight by basically going to a point where the refraction would take place at a rate that the sign shrinks just enough to where now you can shoot the laser to him.
Okay.
I mean, yeah, if what you're saying is true, if I accept what you're saying is true, then yes.
Okay, so what if I started, I froze that sign and I started building up ice on that sign, and I got thicker and thicker ice all around that sign, and I built an iceberg all around that sign. Would the laser still go over the iceberg?
Look, this is the same argument. Anything that's line of sight, right? I can't, maybe not anything, right? But based on this example right here, and these dimensions, right? These dimensions and these measurements, right? Anything that's line of sight, if you're at the right distance, then yes, you'll be able to do it. But not things that are not line of sight. If something is over a curve, it's not line of sight. Do you know what I mean by line of sight? I'm sorry,
No.
It's the same example. He's still line of sight, even though there's an obstruction, right? You being over the curve of the Earth is not an obstruction. That's you being out of line of sight. There's a distinction between the two. Yes, they're related. Okay, I understand. You can't blow. They are related, right? Obstruction and a curve and you being out of line of sight, they're related, but they're not quite the same thing. I hope this makes sense, okay? So you being out of line of sight completely, not the same thing as what you're trying to display here with an obstruction, okay? You're still line of sight here. So you can remove the obstruction, but you cannot change something that's not in line of sight. I mean, that's not in line of sight.
Well, okay, for your information, the height of the sign approximately emulates what Earth curve would be. So this is evidence that it is possible under the right conditions to see over what should be a physical obstruction.
Like I said, it's not the same thing because this is one sign, right? And you would be line of sight. So if you zoom in, listen, let me explain to you, right? You see that curve right there where the laser line is?
The red one, yeah.
If you zoomed in, right? If you zoomed in, right? And it was just all Earth right there, right? No. Zoom out. Not too much. All right. This is what I'm saying. If it was all Earth, right? Look at that red line going at a curve. Imagine that red line is going all the way around, and the ship is not parallel, right, in some random space. It would have to be at an angle. Do you see what I'm saying? The ship would be at an angle on that curve. Do you understand what I'm saying right now? It wouldn't be just So if it's a real curve, think about it. If it's a real curve, if that was the Earth curve and it was on the Earth, it would be at an angle down the curve. You would not see it. It would be down that curve. You would not see it. It would not be flat in random space. For you to think that just shows that you either don't have critical thinking or you're trying to trick me. You think either I'm dumb or you're not quite getting it. All right, I'm not so. All right, dog. Use some critical thinking. All right, if it was actually the curve of the Earth, that means that thing would now be at a different angle, wouldn't it be? Yes, it would be at a different angle on the curve. All right, so let's cut this out. This isn't proof either way, but it's definitely not proof. Like no.
Okay.
Well,
Right.
anyway, that's my answer, and that's my evidence to support my answer.
Yeah, I feel like we should move on to the next question now, because that's probably going to start just going around in circles. So, right, Jesse, give you a minute to ask your question to Ross.
Oh, okay. Let me get to there. I got it right here. All right. If my burning desire, or my burning question, is the shape or contour of the surface of large bodies of water at rest, what would make the most sense? A, measuring that surface, or measuring things, or B, measuring things not connected to that surface, or something else, if so, what?
That's a good question. I'm not sure if that question is for me or for yourself, because you guys like to figure out what the shape of the Earth is by looking up at the stars. You guys like to figure out that the Earth is moving by looking up. Like, how do I figure out that the Earth is moving? Oh, you know how I know? Because the sun is moving. The sun moving tells me that the Earth is moving. That goes exactly opposite of what, I'm not sure if you, I don't know if this some kind of intervention you're asking me for. I'm like, what do you mean? Occam's razor would say, let's take the least amount of assumptions, right? All right, so if we look at the Earth, we don't actually measure a curve anywhere. We don't measure that. You're saying that you have zenith angles. You're measuring angles, aren't you? Right. All right. So let's cut it out. We don't have any experiments that shows that the Earth is curved, other than we see both go over the water. All right. So we also see the Earth not moving. We also see the sky moving. All right. So yeah, it would make the most sense to go by Occam's razor, take the least amount of assumptions. That's why I brought up me having the internet as a kid. I don't believe anything anybody says ever, under any reason, especially not the government. So if you want to show me something, I believe in the scientific method, and if you can show me experiments that are easily verifiable and repeatable, then I would gladly look at that with a serious eye. Absolutely. So it has to be scientific experiments. Otherwise, it's just people talking at the end of the day. It's philosophy.
I'm not sure that answered my question.
Well, ask it again. Maybe I didn't.
If my burning question is the shape or contour of the surface of large bodies of water at rest, would it make more sense to measure that surface, or to measure something not connected to that surface, or something else?
It would be better to measure that surface. That surface.
Good. Thank you.
So are you saying we don't measure the bodies of water at level and flat? Because that's how we navigate the stars, right? We assume that we're on flat, and we take angles. We can't take an angle from a curved surface, so we have to be flat in order to take an angle, don't we? All right, exactly. So we have to be flat to take an angle to the star. We don't?
No.
So you're saying that we measure the sea curved. That's what you're saying. We've measured a curving sea, and we don't use sea level, right, to measure how far we are, right, in certain elevations. Because how can we do that effectively if it wasn't perfectly level? How can we know where we are as far as elevations if it's curving over? Because now it's a different angle and a different angle and a different angle. So I don't know if you understand the laws of physics or just the basic laws of mathematics, but what you're saying right now doesn't make any sense.
Can you see my screen share?
We can see every screen share, sir.
Okay. This is... are they getting old? This is how we can measure...
Hey, go ahead. Yep.
This is how we can measure an angle anywhere without even knowing whether the surface we're on is flat or curved. See the bubble level?
Wow.
This will be level, right? We level our protractor to that, and then we measure the angle relative to level, right? Or we can use a plumb line, right? No?
I'm listening. Go ahead. I'm listening.
Do you agree that this bubble will find level, even if we're
that
on a
bubble?
curved
I
surface?
agree. If you have a level finder, yeah, you can find level using a level finder.
Okay, and that will be perpendicular to plumb at that spot, right?
I feel like we're getting off track because you said to determine the shape of the seas, right? Should we measure the sea or something? Or should we measure the ocean, whatever, or something unrelated to it, right? And I asked directly, have we measured a curve on the sea? And then you tried to go off on a tangent about, because I said, I'm like, because for the most part, we use the fact that the sea is level to measure our angles to the stars and navigate, right? And you said no, and then you wanted to go off on that, but that's a red herring, if we're being honest, right? So do you have measurements based upon what you asked for that the sea curves, that any part of the ocean curves? Do we have curved measurements from the ocean?
Yes.
Go ahead,
And lakes,
pull them up.
too.
I'll take them right now.
Okay. Who's asking whom a question?
Well,
I asked him a question.
Yeah,
Did he answer?
I don't know. Do you
What
feel
was your question?
satisfied?
Well, like, I don't even know how we started looking at it. Like, you pull a diagram up, and I got questions now.
All
Go
right.
ahead,
He
what was
did.
your question, bro? My bad.
Yeah.
That's right. You did answer my question. You said measuring the surface would make the most sense. Okay.
Yeah.
So it's your turn for a question now.
Yep. Okay.
Ask me.
That's it. Okay. All right, I'll go back to the question I just asked. I mean, do we have measurements of curved water,
Yes.
curved sea? Please pull those up for me. I'll take those. I'll take those now.
Hold up.
Curved ocean. Please.
Okay. Can you see my screen share?
You-
Oh, of course you
you-
can see it.
You're not.
So
You're not.
look at my
You're
screen.
not. You're not.
This
You're
time
not
we can't
sharing.
see it.
Yeah. You're not sharing right now.
Oh, let me read. My screen share button's always green, even when I'm not, so I didn't know. Okay, this one is this one. Okay.
Okay.
There we go.
Yes.
All right, so
Just explain to me what I'm seeing. Just explain it to me. Yeah, just tell me what. it is.
I believe he's going to. If you just give him a sec.
yeah. Okay, so what this is the measurements of missing height at different distances. So starting out here on the left was like the closest one was 1.5 miles away. And then they scatter along and all the way up to 105 miles. I took a lot of these measurements myself, but there's also a couple of globers that contributed measurements, and also 2 flat earthers that contributed measurements. Bev used his auto level and published the picture, and so I got an angle from that. And J. Tolan Media got himself a theodolite, like the big boys do, and he measured the angle to a mountain. And so this shows the drop over distance at multiple locations, and as you can see, they form a curve. So
Okay, so you're saying that they are on the water, and they're measuring their angle from the water to a mountain?
they're measuring. No, they're not from on the water. They're from a location of a known elevation, measuring the.
How do they know the elevation?
I got them from Google Earth mostly, but some of them I checked myself if they're close enough to the water.
There's a hole in your experiment right there, a big one. But keep going.
Well, no, actually, I've been checking Google Earth against barometric pressure altimeter data, and where I can, I actually measure it.
Data
from
from
sea
who?
level.
Data from who?
Well, I got a barometer, and I can measure
you're
the
saying
barometric pressure. Yeah, you can get an app for your phone that literally uses the phone's sensor to show.
To tell you how far you are above sea level.
Well, it shows you the pressure, the atmospheric pressure in millibars,
And that's
And-
how you know where you are.
and there's a formula that you feed that into it, and it tells you your elevation. That's airplanes have been using barometric altimeters for how long have airplanes been flying?
Long time.
Yeah.
Okay. And your claim is that nobody was on the water when they took these measurements, but somehow this proves to us that the water was curving.
Here, let me go to this
'Cause
diagram.
that was my question. Because you brought up how do we know, how should we figure out what the shape or what bodies of water are doing? And so I'm like, okay, so what measurements do we have that the water is curving? And your exact thing was, should we measure things that aren't related to the water? Should we measure the actual water? So that's why I asked for actual water measurements.
Okay. Reference my screen share. If we've
I'm
got an
mounted.
observer on a mountain of a known height, and he measures the angle to the top of another mountain at a distance of a known height, see, both of these mountains are measured, their height is measured relative to sea level at their location, right?
How did they know what it was relative to sea level? How did they get that information? If they're on a mountain,
Surveyors are pretty smart. They get it right. That's why airplanes don't run
surveyors
into
are
mountains as
pretty
often.
smart.
Yeah.
You wouldn't accept that as an answer now, would you?
But no, seriously,
Come on, you're a smart guy.
Didn't you already,
get a barometric.
Jesse? Didn't you already answer that by saying it's based on the barometric pressure? Just to clarify.
That's, well, no, that wasn't my answer. My answer was that they're surveyed. Mountains are surveyed relative to mean sea level.
Okay, there we go. So now my thing is, okay, first of all, we're relying on data already, right? So that's a hole in the scientific experiment if there was one, right? But these are observations, so it's okay. But there's a hole in that data because there's a lot of variables right there, right? People collecting data, human error, natural stuff that happens, right? And then if they're measuring it from sea level, now that's also ambiguous too, because we're claiming that the sea actually curves, right? And then there's also a whole bunch of obstructions, right, that go on between visuals. And then we've already discussed refraction. There's all these different variables that come in, and this is why measurements, right, aren't proof. This is why observations aren't proof. Because now there's 50 different variables that could affect these certain things that might give us the data. And even though the data is consistent, they could be consistent in variables. So there is no proof necessarily in just observations. I'm sure we can both agree on that, right?
That's more into semantics. There's evidence, and evidence has a level of confidence. You can be extremely confident that some evidence proves something to you, or you can be mildly or not at all confident. There's no such thing as absolute proof of anything, except to oneself, perhaps. But maybe this will, because you'd ask me to see evidence of water curving, right?
Yes.
Okay, so maybe this one will be simpler for you to understand. Here's
look, let's be clear though. I understood the last one. I understand every single thing you're saying. I just don't think that they are valid answers, right, to the questions. And I definitely don't think, even if they were valid answers to the questions, that they are now conclusive evidence of your claim. Absolutely not. They're not conclusive by the least bit. So I want to make that clear. It's not that I don't understand it. I understand it very well. I just disagree with what you're saying. No. Yeah. What you're saying makes sense, but it doesn't then follow that now we know the Earth is curved. Hope that makes sense.
Well, you disregarded it for reasons that are not good debunks because, for example,
Really?
Yes, you said because maybe the Google Earth elevation is off, and I'm saying I've measured.
You don't think that human error happens when it comes to land surveying? That's what you think.
Try not to overtalk, Ross. Give him a chance to finish his sentence before you respond, if that's okay. Right. Back to you, Jesse.
Okay. All right. So, I've personally checked several Google Earth elevation locations with a GPS receiver and using barometric altimeter, and I found them very close. So it's not really a solid argument to say, well, Google Earth elevations are wrong and surveyors just totally messed up all the mountain surveys because, we'd have airplanes flying into mountains all the time if mountain elevations were wrong, right? So
that's wow. Definitely a false dichotomy right there, but no, that's not true. But I do want to deal with your pressure thing. You're saying that your independent check that the elevation is correct is basically because you can tell what elevation you're at based upon the type or amount of pressure you're sensing in your barometer.
Yeah.
I'm trying to say it easy so everybody understands it, right? That's what you're saying, right?
Yeah. Let me change my screen share here.
Okay. But just so if that's the case, right? If that's the case, so you're saying that there are no variations, right,
in Earth's type or amount of pressure, right? Based upon, I don't know, time of the day, temperature, that doesn't affect the actual pressure at all? Or
Sure,
does it definitely affect the pressure?
well, the pressure changes all the time, but how
Okay,
airplanes...
okay. So then it wouldn't necessarily be
Ross,
sufficient to say that we know for sure.
Yeah, give him a chance to respond.
Yeah. Just to let you know, airplanes, when they're flying, they adjust their altimeter for the current sea level air pressure. So they get a radio transmission from the airport that says, set your altimeter to 30.1 inches of mercury or whatever. It's a pressure, or it could be millibars or whatever. So the pressure does change, but if you set your altimeter to be aware of the sea level pressure, then it can accurately give your elevation. So here's the tests I've been doing so far. I just started this the other day. Here is, are these numbers readable, or is it totally useless?
No, I can see
they're
them fine.
readable and also at the same time useless. I'm trying to be a nice guy, Jesse. I really am. But none of this is evidence. I mean, they're readable, but they're also useless at the same time. And I don't claim you to be a liar at all. You feel me? But I just want us to be clear, though, that even if you did do this, right, there are so many other variables that make this maybe untrue, but even if true, not conclusive evidence at the same time. So we could talk about this till the cows come home, and you could even be right on this, but then that still wouldn't prove to us that the Earth is curved.
Yeah, but the point is, it suggests to me...
Let me correct myself. I'm sorry. Let me correct myself. Right? It doesn't. It may prove that the Earth is curved. It doesn't prove that the Earth is an overall globe, right? Because the Earth could have many different shapes, and we have no idea what the Earth actually is, right? So it doesn't prove any of that. So if we start off from we don't know anything, show me the proof of what you got. That's only proof that, there's a curved surface from here to there. So you've proven that there's a curved surface from here to there. That's it. But not that there's a whole globe of curve.
Well, let me just respond to the question of whether Google Earth elevations are accurate. Here you can see, for example, at my home, Google Earth says 432 feet. My GPS says 435 feet. And using barometric calculations, it says 441 feet. That's all three of those measurements fall within 9 feet of each other. And I've got 4 other measurements here.
So what did we learn about margin of error just in that one collection of data? What's our standard, I guess, deviation for the margin of error, maybe? Or excuse me, the standard deviation between, or what's the margin of error? Because we technically don't know what the real answer is now, because we got 3 different recordings, right? So we basically know that our answer is somewhere in between here and here, maybe, because all those recordings are different. It could be a different elevation. Isn't that true?
Well, of course it's different by some. For example, my worst reading, the barometric pressure was off by 14 feet, and I wasn't even using a current sea level pressure reading, because I didn't have one available. So,
okay, but real quick though, is what I said true though, right? You said you got 3 different measurements, right? So I mean, normally just to be safe, we would probably go with somewhere in between those. But isn't it true that it could also be something different than those 3, even though we got those 3 measurements? Isn't that true?
Huh?
You don't want to say that's true, even though we all know it is?
Well, if 3 different types of measurements all fall within a few feet of each other, then that's not really a good excuse to explain why there's 6,000 missing feet.
I just asked,
right?
Is it true, right? Because let's say the measurements are 1, 3, and 5, right? Is it possible that the real measurement could be 6? Is that possible or no?
Yes.
It has to be between 1. Let's not make it too complicated.
But it's not very likely.
It is possible though, right? Okay, cool.
But it's not very likely that it would be 6,000. Do you see what I'm saying?
I agree. It's not likely,
Okay.
but scientifically it's possible. See, I'm on the side of science. I want clear scientific theories. If I'm going to claim that if I'm going to claim that something should be taught in schools to kids as science for real, I need clear scientific theories, and it's a rigid process. I'm sorry, it's not philosophy.
It's not a rigid process.
Okay, so did I answer your question then? I don't
Yeah,
remember.
you did. Yeah, I'm like, that's why I'm like I said, not that it wouldn't be pretty good evidence, right? Yeah, I always give you that. It's like, even if you have 90% evidence, right, which you might, yeah, maybe you're 90% sure. But now once we get out of the realm of statistics, out of the realm of math, out of the realm of guesswork, and into science, it has to be rigid now. Now we need experiments, or else you don't really have a scientific theory. That's why I say we know for sure the Earth is not moving. That's why I say we know for sure that the Earth is in the center of the cosmos based on all observation, right? Because we've done experiments, and those experiments have led us to that result. All of science agrees. So if anybody disagrees with that, then you're technically a science denier. If you think the Earth is moving still, you're a science denier.
Okay, so in response to your comment that maybe the elevations was wrong, I've shown that all three elevation methods correlate very closely, showing a few feet of deviation, not thousands of feet. In response to your claim that the surveyors may have messed up and got the mountain elevations wrong, that's not a good argument, because it would be a really funny coincidence that all the mountains just happen to be missurveyed in such a way to form this curve. Not to mention that Mount Shasta would have to be about 8,000 feet high instead of 14,000 feet high. So that's like a huge error. And you'd think that somebody would have said, you know what, we don't think Mount Shasta is really 14,000 feet. And at the end of the day, hikers go up all these mountains with barometric altimeters, which don't depend on GPS, and they don't depend on Google, they don't depend on satellites or anything. They just base it on the reducing air pressure. And if Mount Shasta was only 8,000 feet instead of 14,000 feet, they would have reported that.
They would have recorded that. I don't know if I want to call that a false cause or just an absurd statement. You know what I mean? But, or I guess circular reasoning. They would have recorded it if so. I don't know. Reification fallacy, is that 4 in 1? You're going to beat Craig for the record of the most fallacies in 10 seconds. Shout out Mind Shock.
Mind Shock is dumb as fuck, man.
Yeah, like I said, that thing that I brought up about the surveyors, right? That was just one of many holes that I brought up. And then when you brought up like, oh, these are the elevations recorded from my house, I'm like, okay, well, there's another hole. You see how this, like I said, this is why observations aren't the whole scientific method. All right, the beginning of the scientific method is observation, yes, and then hypothesis, right? But you have to run experiments, right? And then those experiments have to be repeatable and testable. So if you haven't done that, then at the end of the day, what you're saying is speculation. At the end of the day, it really is scientifically, it's speculation. So I brought up the surveyors, and then I brought up the variation of distances, and then I brought up the fact that the water is moving, right? Are you guys just assuming that the water is where it's at? You're assuming that it's there, or are they actually measuring the distance to the water while they're on it? Because if they're doing that, then there's a whole bunch of variables there. Are they actually around a curve? Is the water moving, right? Well, we have no idea. The curve could be shorter or longer. We don't know what the actual geography of the Earth really is for us to say that you're 100% level just because you take a measurement right there. That's
Is
a
that
fact.
an argument? Is that an argument from self-imposed
I'm
ignorance?
poking holes in your argument. No, I'm just poking holes in yours. It's not my argument.
Well, maybe this would be simpler for a simpler response to your question of show me or to show you water curving. So in this
Right,
case,
that's what I asked. Think about it. There's a lot of mountain measurements.
right, this one's not a mountain measurement.
Oh.
I was hoping you would understand that mountains were surveyed relative to mean sea level in their area, but this is simpler because
But that is not a flawless process. I understand it. All right, I would advise you to stop saying that. All right, trust me. I understand everything, every word that comes out of your mouth. I understand it. That don't mean I have to agree with it or think that what you said made sense. I understand it. That doesn't mean that it made sense. I hope you understand that. Right. Like if I say dog park, think about it. If I say dog park boy, you understood that, but you also understood that it didn't make sense. That's you talking right now. Blah, 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 blah. I understand what you're saying. None of it makes sense, buddy.
All right, Ross.
Sorry, about that.
Yeah.
Okay, right. Should we move on to the next question?
Is it my turn to ask you a question, or
could I
no,
comment?
I just asked you a question. Yeah, you're asking me one now.
Yeah, can I comment briefly on the picture I have up?
Yep. Quickly, that last thing on this one, and then we move on to the next question.
Yeah. So this, I was standing at a location, and I actually measured my distance down to the water, so I know I didn't have to rely on Google Earth or GPS or anything else to measure my distance down to the water. And I measured the height of the ship going along this path.
Right.
And so this is a pretty simplified. I don't depend on much of anybody or anything else. And if the ship was moving on a flat surface, it should have been the same height of ship the whole way. But it measured as if it was moving on a curved surface. I'm done.
Okay, cool. Right, so
Can I get 30 seconds real quick or no?
right, last thing, and then we move on to the next the next question from Jessie. All right.
Right. Yeah. The last thing on that ship is like you have to understand that we've already discussed refraction a number of times. So when you take those measurements, you already know that those measurements are not right. Think about it. What's the height of that sign over the right? You proved it already in your demonstration that depending on the angle and how far you are, you can't get accurate measurements about what the height is or what the elevation is. You know why? Because guess what? The sign could be below the thing even though it's above it. So you debunked that already in your own presentation. So those aren't accurate measurements. We have no idea what's going on. The ship could be moving right along the sea. Think about it. The ship could be moving along the sea. There's waves that happen where it dips down for a little bit and then comes back. You have no idea all the variables that go into that, to that observation,
That wave had a radius of 3959.
All right.
Okay.
Yeah, your question now, Jessie.
All right. If my own measurements and observations all point towards a spherical surface, then wouldn't it make sense for me to conclude that Earth is likely a sphere?
If they did that, then yes, absolutely. It would be likely for you to conclude it. But if you told me that, I should not take your word for it, because then I would be not like you, because you're actually showing measurements, right? I would be like all the other people on your side who say, hey, look, this guy did these measurements. Look, this guy did these measurements. I would be like them if I said, oh, wow, you did the measurements, so let me believe you. But if you did the measurements and they came out that the Earth is curved, definitely, then it would be reasonable for you to believe that 100%. For you to believe it.
All right, thank you.
But now you would have to recognize that you're believing something, and that makes you religious. You believe. Well, I guess maybe
believe.
I observed a little bit, but it's not a scientific belief. It's just a belief.
You
Religious.
believe the Earth is flat. Is that religious?
I don't believe none of that.
Oh.
Remember, if you pay attention to my opening, I specifically said this first thing proven. This second thing, it can never be proven. The third thing, you have two options. Either we're living on a horizontal surface, or the globe, which this is a possibility, guys. The globe is just so big, and they're lying to us about the other lands that exist, right? Because that's a possibility. The globe is so big, they're hiding other land, they're hiding other resources, and so the radius is wrong. Those are your options. So I didn't say that I believe in a flat Earth at all.
Okay, are you happy with that, Jessie? Move on to the next one?
Yes. He basically agreed that with the information that's available to me from my own measurements, that my conclusion is fair enough, is good enough.
Yeah, I would never fault somebody for saying, like, no, this is what I saw, so I believe that. Of course, you know what I mean? But I'm going to, of course, challenge it for the good fun, So my question is, if all scientific evidence, right, all experimentation shows us that the Earth is not moving,
it doesn't.
Would you be a science denier technically? Now, let me not even make it that kind of. All right, forget the science denier part. All right, if all scientific experiment shows us the Earth is not moving, would it be reasonable, right, for me to say that I'm on the side of scientific experiment to conclude that the Earth is not moving, if that's true?
If it was true, it would be, but it isn't true, so it isn't.
Are you sure? So are there experiments that prove the Earth is moving, sir?
Yes.
Before we go to this, do you want to bet? Because I already got 150 pound coming from FTFE. But if you want to bet on this first, sir, I'm just kidding.
What's that?
Go ahead. Pull up
he said, do you want to bet on it there being experiments to show that the Earth is moving?
That have proved it.
Okay. Do you have any qualifications you want to put on that first?
But for the bet, that would defeat the purpose of the bet. That's why I'm betting on it.
Well, no,
like, do I have the evidence for it? Yeah, I got
no. He's asking for like rules to the bet.
Yeah.
Oh.
What kind of motion? See what I'm saying?
I said if I'm not mistaken, I said there has been no experiment that has proven that the Earth is moving around the sun. The Earth is not moving.
Around the sun. Okay. So you just said moving.
Okay, my bad. Go ahead. I can clarify what I'm saying. Either way you want it, there are still no experiments that prove the Earth is moving. What you think that they measured in the Earth rotating is a sidereal rotation, which matches up with the movement of the sun. You understand what I'm saying? So if the sun is moving,
so just to clarify what you're saying, Ross, are you saying that there is no experiments that show that the Earth is either orbiting the sun or rotating around its own axis?
Yeah. There. Number one, 100%. Number two, there are experiments that show that it could be either that or the sidereal rotation. So it hasn't proved either way. In that second, yeah.
Yeah, and could you define sidereal rotation for us?
Well, basically, like assuming that there's assuming right, which is all pretty much all physicists agree at this point, right? Assuming that there is an ether or a medium, right, that exists for light to propagate through, right? As the stars move around, there's a transfer of motion down to the Earth, similar to a wind, right? In Russia, the Russian scientists that study the ether, they basically describe it as an ether wind. So there are tons of published Russian physicists who not even like talk about this, but like this is a huge part of their belief system right now. As far as, I mean, it's a huge part of ours too, but most people just deny it, right? So as the stars move around, right, it basically transfers a motion down to the Earth. The easiest way to understand it is like a wind, right? Like if there's a bathtub and I'm waving my hands, the wind is going to move the water on the bathtub. So that would be the exact same, I guess, degrees, right, that they claim the Earth is moving. But here's the funny part about that. They've never proved the Earth is rotating. How did they figure that out? They figured that out by mapping the stars. Are you aware of that? Right? How did they know the Earth was moving? They based that on what they saw the stars doing. So even if you're claiming that that's proof that the Earth is moving, that wouldn't be, that's still circular reasoning, because there was no proof anyways. It was just an unfounded claim. So your proof of it moving can't be the fact that, oh wow, we sense a motion and that motion is consistent with what we think the Earth is doing. You have to prove that the Earth is doing that first.
Okay,
I
did ask you to define what a sidereal day was, just for everyone watching, and that wasn't it. A sidereal day, just so everyone's aware that's watching, is the period of time it takes for the Earth to complete a single rotation on its own axis with respect to the stars.
Well, allegedly, it could just be the stars moving, though.
Well,
no, that is what the definition of a sidereal day is. Just so you know.
Well, I know that's the definition, but it's not a scientific one. That's not true, because we observe that by seeing the stars move.
Okay,
observation shows us the stars move. We do not witness the Earth moving. So before you tell me that's proof of the stars moving, you have to
no one's saying it's proof. I'm not arguing or debating here. I'm just saying that that's what a sidereal day is. A sidereal day, it is different to a solar day. You know,
I did misspeak when I said that. My bad.
Yeah,
I misspoke when I said sun.
So it's the difference in like.
I was wrong when I said sun. I was wrong.
Yeah. So it's the difference in how long the Earth takes to rotate on its own axis compared to what 24 hours is. Okay. So
yeah. Thank you for correcting me on that. I meant as the movement of the stars. Excuse me. So yeah, it's as it relates to the movement of the stars. So we haven't observed the Earth moving at all, so it can't be a scientific theory, right? Without instead one an observation. And there's no point in betting me at this point, because I just gave away the whole thing. It's like, bro, I know for a fact there's no observations out there. I mean, there's definitely no experiments, but there's no observations out there of the Earth moving. Not an observation. No. You saw an effect, right, in an experiment with light, and it could be one of multiple things. We never witnessed or observed the Earth moving, so it can't be a scientific theory.
So scientifically, we can actually measure the angular motion of the Earth around the sun. And
Ow.
can you see my gyroscope here?
I see it.
Okay.
Yep.
It's spinning inside there, and this is just an old aircraft gyroscope I took apart, but it still works.
Okay.
So I can pick this up, and I can rotate this, but the inside stays stationary. See how that works?
I'm quite aware of how a gyroscope works. Yes.
Okay. So what I'm saying is that there's only one known cause for this gyroscope. If it were perfectly balanced and everything was tuned up perfectly, there's only one known cause for this to show a relative angular motion, and that's due to observer motion. There's only one known cause for a gyroscope to show apparent drift, and that is observer
let me ask you
rotation.
this. Let me ask you this. Even if it was true that there's only one known cause, does that mean that that's for sure the cause because there's only one known cause?
No, but you can't just make up another untestable one just and
But
say
we also
that's
have to
it.
use logic, though. But we also cannot discard logic. And what you just agreed to was logic. You had to agree to it, right? Because it's logic. So let's not throw logic out just because you have something in your hand, all right? So just because there's only one known cause, and that's not even true, though. But
Yeah, but see,
just because, even if there was, though, that's not.
scientifically, we can say, you know what? We have one known cause. We can't scientifically say, well, but my belief in whatever requires there to be another unknown cause, so there must be another unknown cause. That's not science. It's science to say we have one known cause, maybe that's what's doing it. It's not scientific to say we have it. What?
Level.
That's only the beginning of science, all right? That's the beginning. Observation, what you're describing is an observation and a hypothesis, buddy. That's not what science is. No, science is you have to keep going now. Now you got to do some experiments, right? Yeah, multiple experiments. Then you have to examine the independent, dependent, and control variables, right? And then after that, then you have to publish your data, and then other people have to repeat your experiment in order for you to have a scientific theory, all right? So what you're talking about is not how science works, buddy. What I'm talking about is how science works.
So because you stated this as it being scientific that Earth had no motion, and you didn't want to call me a science denier, and I appreciate that. And so now I'm asking you, how using the scientific method did you determine that there is another cause for the gyroscope showing apparent drift? Where's your control variable and your independent and your dependent variables on your claim that something else is causing the gyroscope to show drift?
You're already familiar, obviously, with Michelson and Morley, right? And Michelson, Gale, Pearson, right?
Yes.
All right,
but that's not angular. Michelson Morley was not an angular experiment.
I just relax for a second. All right. So I heard Toon say this right in a debate with Whitsitt. He literally said, because Whitsitt asked him, "How can we prove that the Earth is not moving? What experiment do we do?" You know what he literally said, word for word. I wish I would have recorded this before. He said, "You try to test motion and get a negative result." Word for word. Do you agree with that, or you don't agree with that? If you test for motion and get a negative result, does that mean that now you have created an experiment that has shown that more than likely it's not moving? Do you agree with that or no?
If you have a proven way to test for motion of that type, then yes, that's a good argument. The problem is, and Whitsitt doesn't like to say this, but we have no known way to test for the linear or displacement component of the motion. So it's like if I said to you, this device I just made you detects X, the presence of X, like radiation. Let's say I got this radiation detector. It'll tell you it'll tell you what the radiation levels are, and you turn it on and it says 0. And I said, see, there's no radiation. And you say to me, Jesse, have you ever tried this with a known radiation source? And I says, oh no, but it should work. Are you gonna depend on that? No, you want something that can be put in a known radiation level, tested, and shown to actually accurately read that radiation level. And we have nothing that has been put on a plane, train, or hearse and moved at a known velocity and been able to measure the actual velocity of that jet. So that's the problem with the Michelson-Morley argument.
All right. So my screen is up, right?
Yeah.
Let us read together, class. The second class of facts to which we have alluded has reference to the question whether or not the motion of the Earth in space can be made perceptible in terrestrial experiments. Shout out Whitsitt. We have already remarked in section 5 that all attempts of this nature led to a negative result. Before the theory of relativity was put forward, it was difficult to become reconciled to this negative result for reasons now to be discussed. The inherited prejudice about time and space did not allow any doubt that arise as to the prime importance of the, I think we get the picture. Okay, so my point, right? So we don't get too far off, right? Did I take the share screen off? I'm sorry.
Can I say something quick? I've argued with Whitsitt
Let me just finish my point real quick. So, because this is from Einstein's book, even though it has this is from his book, right? So this is my point, right? All physicists agree, and I can pull up quote after quote after quote of different physicists, not just Einstein, that all agree we will never be able to prove scientifically that the Earth is not the center of the universe and that the Earth is moving. Okay, so now if you don't agree with that, you might not be quite as informed, or maybe you just don't agree with them, and that's fine. I can respect that you don't agree with them. But like I said, that was the result of Michelson and Morley, though, right? Whether we like it or not. And then there's always my favorite experiment, Airy's failure, that I bring up. Are you familiar with Airy's failure or no?
Is that the water-filled telescope?
Yeah.
Yes, you're familiar with that. Okay, so these are two separate experiments, right, that you can do that show we are not on a moving platform. Two different experiments, all right? So I'm not saying that you're necessarily a science denier if you don't believe him, because I didn't do the experiments myself, right? So I'm still appealing to authority, right? But if we're saying which side actually have experiments that back it up, well, I would have to say that I'm appealing to scientific authority, and the ones who are on the other side are appealing to their own denial of what the scientific authority is actually claiming at this point. Because they claim that we don't know that the Earth is moving and that it looks like it's in the center. That's what all scientists agree on right now.
No.
So the problem, though, is exactly what I was telling you about. The water-filled telescope, and neither the water-filled telescope nor Michelson's interferometer have been put on a jet and shown to actually be able to show the velocity of the jet. Einstein might actually be right. Maybe relativity is true. See, that's it. We don't know.
Are you saying those experiments?
Hold on. Let him finish his. Let him finish his thought before you interrupt. Sorry, Jesse. Carry on.
All right. If relativity is true, then Airy's failure and Michelson-Morley's failure are are both exactly what we would expect, even if the Earth is orbiting the sun. So until we can put that telescope and put that interferometer on a jet and show that it actually works the way that original experimenters thought it would, that it's not evidence that the Earth is not moving, because it's not been shown to be able to measure the tangential or displacement component of motion.
That's interesting. That's why I asked you before, point blank, if we do a test that proves that, if we try to test that the Earth is moving and we come up that it's not, then that's our scientific experiment that shows that it's not. So you admitted that at first, and Einstein himself admitted that the equipment that they used was over 10 times as sensitive as it needed to be in order for them to be able to detect the Earth moving. This is the fact.
No.
Let me ask you this.
I want to ask a more direct question, though, because I don't want to get lost in these weeds, right? Like I said, let's just keep it simple, all right? So we all agree, I would hope, that in order for it to be a scientific theory, you have to have experiments, right? Which experiments did Einstein run for his quote-unquote scientific theory of relativity? Which experiments backed up the theory of relativity?
I think he relied on existing observations.
So none, right? We agree none. So then the theory of relativity was never a scientific experiment ever, all right? So every time that you say, if the theory of relativity is true, if the
theories aren't experiments. I don't know why you're mixing that up.
No. Scientific theories come from experiments. Yes, they do.
Ross, could you define a scientific theory for us, please?
Yeah, it's the result of an observation, right? Followed by a hypothesis, followed by an experiment, right? And then followed by is that what you're saying? Is that what you?
Well, no, I'm asking for the actual definition of a scientific theory because you keep saying that, but I'm not entirely sure you know what a scientific theory is. Well, no, I'm asking for the definition of a scientific theory. Do you know it?
Well, there's a whole bunch of different definitions. There's different.
Well, no, there's one definition of a scientific theory.
No, there's not one different definition.
No, yeah, of a scientific theory, there's one definition.
You're
Do you know
telling
what
me
that
if I
is?
look up Library Britannica and some random Google search, it'll have the same definition? Are you sure?
Yeah, if you looked up scientific theory, there's one definition.
Right? It'll say the same thing, right? Essentially.
Yeah, so do you know what a scientific theory is what I'm asking?
Tell you what it is, all right? A scientific theory is a theory that follows a scientific method. Anybody in the audience can understand that, even if you can't read. Okay. Follow the scientific method. It's not a scientific theory.
Okay, so again, I'm not debating. I'm just going to correct you here. I'm quite sure you don't know what a scientific theory.
You would just be appealing to authority, though.
No, I'm just so you know. I'm just going to let you know actually what a scientific theory is because what you said there was completely wrong.
Based on who though? Based on who?
Based on what a scientific theory actually is.
From where though? Who's saying that? Who's the
science?
You're appealing to?
Science.
What do you mean science? Who is science?
Everyone that does science, actually, what a scientific theory is. It's not. I'm not appealing to authority. I'm just going to tell you what a scientific theory is. Right. So a scientific theory, again. So a scientific theory is a collection of all of the knowledge about a specific thing, including laws, including. No. This is what it is. It's not what I say. It is what it is.
Based on who? You're saying that.
Based on the definition of a scientific theory. That's it. I'm just telling you what it is. This isn't an argument. It's just what it is.
Where are you reading it from? Where did you read
it? I don't need to read it. I just know what it is. I'm telling you what it is.
You pulled it out your ass.
No, I'm telling you what it is.
Out of nowhere.
Ross, again, this isn't an argument, bud. I'm just telling you what it is.
Why are you so afraid to say that you read it in the dictionary? You're appealing to the dictionary's authority.
No, again, it doesn't. This isn't an argument. I am just letting you know what it is. The same as letting you know what 1 + 1 is 2 is. I am just letting you know. For your knowledge, what a scientific theory is.
2 can be verified. How do we verify the definition that you're saying is correct? Where do we verify that at?
You can look it up, but I'm just letting you know that is what a scientific theory is. Right, okay, this isn't an argument, Ross. I was just letting you know, and for the audience's sake.
You're smart enough to know where I'm leading.
Yeah, Ross,
you don't want to answer that question.
Hold on again. This isn't an argument. I'm not debating you. I'm just letting you know, and I'm letting the audience know.
Don't interject your fake definitions into our conversation.
Again, Ross, hold on, Ross. I am the moderator, Ross. Stop, Ross. I am the moderator. You will stop when I am talking, right? I am letting you know, and I am letting the audience know what a scientific theory is. So don't interrupt. I am just, for the audience's sake, going to clarify what a scientific theory is. The scientific theory is our collection of all of the knowledge about a specific thing, including laws, including mathematics, including experiments, including observation, including all of our knowledge and understanding of a specific thing. That's what a scientific theory is, the same way that music theory is our collection of knowledge about music. Driving theory is our collection of knowledge about driving. A scientific theory is a specific thing. Okay, anyway, we've got time. No, again, that wasn't a debate. There's no questions. We debate that in ours. I was just for the audience's sake, okay? Right, but yeah, so whose turn is it to ask a question? We'll have one more question, and then we're going to read Super Chat so that you and I can then have our debate. So whose turn is it to ask a question?
I think I asked the question last, right? Did I?
I believe so. So Ross, Ross, your final question, yes.
Can we have valid scientific theories without experiments? Valid scientific theories without running experiments. Is that true science?
I think experimentation would be a very important part of it in most cases.
I think I would agree with you, sir.
It's hard to say never, but there could be a situation where that wasn't the case, but in the type of stuff I do, experimentation is very important.
Amen. I would agree, and I would go as far to say that you cannot have a proper or valid scientific theory without experiment. The defense rests, Your Honor.
So.
All right. Okay. If that. Sorry. Go on.
What would be the experiment in the claim that the stars moving is what caused my gyroscope to do apparent drift. Where's the control variable in that?
Well, for us to prove for sure that the stars are moving, that's not a proper scientific theory. We cannot get up there and run experiments and actually control variables between here and the stars. We really can't. And we've never been up there. So there would be no valid scientific theory that proves what the stars are or what they're doing. We only base that on observation, right? And I guess what we do know based on all observation, though, is that the stars are moving in a perfect clock that tells us what time of the day it is, what day of the week it is, what time of the month it is, and what time of the year it is. And they even tell us, it's like almost like they're counting the years for us. The stars and the moon and the sun, that's really all we know for sure, because we can see that's almost like a natural law at this point. We observe that every time. The sun coming up and rising. The sun coming up and rising. The moon, right, every month, right? The stars every year. So but it's only observation, so it can never be a proper scientific experiment. I mean, excuse me.
So I could deny the claim that the stars are what's causing my gyroscope to drift, and that wouldn't make me anti-science, since it's not science to begin with, right? Okay,
heck no, exactly. Well, it is science, but it's not conclusive to that point, though. That's it. It's not conclusive to that point, but it's not conclusive either way. That was my point, though. It's not conclusive. We're at the end of the day, we're still at ground zero. You don't know, I don't know. You know what I mean? It's like we can lean on what these other scientists have told us and come to our best conclusion. But like you said, unless you do the experiment yourself, that's why I wouldn't call you a science denier, because you're actually out there doing it. So hey, fuck it. I don't agree with what you say, but at least you're actually trying to get out there and experience it for yourself.
What do you think about my measurement of drop over distance? If I am measuring drop over distance, and I have a hypothesis that I will measure drop over distance if Earth is curved, and I measure drop over distance, I've got my control variables, I've got my independent variables, because I'm controlling the distance between the measurements. My dependent variable is the amount of missing height. So it's a scientific experiment, isn't it? And it fits.
You can't control the amount of refraction, right? Not even just from the atmosphere, but also from your horizontal eye zone, right? You have no idea. Like I said, Euclidean geometry is not always valid. We have to throw it completely out when we take long distance measurements, because that's your whole argument for the boats going over the horizon, right? Or not the boats going over the horizon.
Hey Ross, just for the audience, could you define Euclidean geometry for us, please?
Well, for the audience, right? Not all of my audience is smart, right? It's just basically like us looking at our basic geometric angles, right? How we, like I said, listen. It's basically this. Like I said, the way that we can measure angles, right, up close, because light bends far, that geometry that we use up close does not work.
So I've actually done right to left
that's what I'm saying.
measurements.
I'm sorry, real quick. I'm sorry, because that's what I'm saying, right? In the midst of Craig's attempted red herring. You know what I'm saying? That's my point. My point is the geometry that we use when we're looking up close, it does not work when we're looking far because light bends. Do you disagree with that, Craig?
Sorry, I was just asking for you to define Euclidean geometry for us, and you
agree with that?
You completely failed to define Euclidean geometry.
No, do you disagree that the geometry that we use when we're looking up close does not work when we look far because light bends?
I disagree with that. Absolutely, yes.
Really?
Yeah.
Yeah. So,
okay.
If you see my screen share, that's right. You always see it. Oh, well, sometimes you do. You don't.
So real quick. So how do train tracks touch in the distance, Craig? I'm sorry, I know this is between me and you, but it's like, how does he say this ridiculous shit and get away with it and nobody calls him on it? What do you mean? How do train tracks touch in the distance, buddy? If Euclidean geometry still works, go ahead.
Train tracks don't touch in the distance.
Oh, right. Craig is a science denier. He's a science denier, a visual denier, an observation denier.
Are you saying that train tracks actually touch in the distance? They don't. They appear to converge. They do not touch.
Oh, they appear. Right? So we can't use Euclidean geometry when things are curving and appearing to come together, right, Craig?
Train tracks aren't curving. Train tracks are parallel.
How do they go from here to here? Unless they curve.
They're parallel, dude.
Not apparently. Apparently they're not. So the light must curve, right?
Are you saying train tracks aren't parallel?
I'm saying the light curves, doesn't it?
Yeah, that doesn't stop train tracks being parallel.
But it stops us being able to use geometry to measure what we see.
No, not at all.
Bow. Yes, it does. Yes, it does. Bow.
No.
It's not the
Anyway,
it's not the curving light that makes train tracks appear to converge.
Yes, it is, because we aren't seeing the train tracks. Light is bouncing off of, we're seeing light. We're not seeing. Do we really have to light? I don't want you guys to get us dragged down to this conversation, dog. Listen,
okay, right. Was that the has the final question been answered? Are we? Well, I just want. Has the final question been answered now? And then you guys can have final thoughts, and then I'll read super chats.
I'm sorry.
Yeah.
Craig just triggers me so much.
Yeah, I think we're ready for finals.
Okay. Right. Jessie, I'll let you have your final thoughts first. 2 minutes. Over to you. Final thoughts.
All right. Well, regarding angles and distances, I've done some tests, which you can see on my screen here. I was on Mount Scott, and I measured the angle to Mount Shasta and Mount McLaughlin.
Sorry, I stopped the screen share.
Oh, and Mount McLaughlin was 36 miles away, and the angles and the distances matched up perfectly. So it's not true to simply say that light is unreliable at great distances. It can be, and in fact we find it's reliable uncompensated in the right to left axis, and it's reliable in the up to down axis, except it just has an 8 inches per mile squared offset to it. And other than that, I think I've shown that my position is very reasonable based on my evidence, and thank you, Ross, for debating me, but with all due respect, I don't think you brought any evidence to support your position or to debunk my position. So, thank you.
Okay, Ross, final thoughts for you, bud?
How much time do I have for the ending?
2 minutes.
Okay. I'm just gonna do a quick sheet, last minute screen share. Just, like I said, in this essence, I am appealing to authority, but I want to let you guys know that I'm on the side of what all the astrophysicists, right, and astronomers are saying about our planet right now. All right, so I already talked about the experiments that prove the Earth is not moving. This is about why the Earth being the center of the universe, right? So this is astrophysicist Jonathan Katz. No longer could astronomers hope that the Copernican dilemma would disappear with improved data. The data were in hand, and their implications inescapable. We are at the center of a spherically symmetrical distribution of gamma ray burst sources, and this distribution has an outer edge. That's interesting. I had to put it twice on. This is my favorite guy right here, for real. Like, my favorite guy. And honestly, out of all the scientists, he's the easiest one to listen to. He's a great speaker. When you look at the CMB, right? This is what science is saying right now. This is the latest in scientific research, all right? But when you look at the CMB map, you also see that the structure that is observed is, in fact, in a weird way, correlated with the plane of the Earth. Weird. Around the sun. Weird. Is this Copernicus coming back to haunt us? That's crazy. We're looking out at the whole universe. That would say we are truly the center of the universe. Shout out the physicists that I appeal to and rely on, so that way I can always be on the side of science and not be a science denier like some other people, okay? So I just like to read, modern scientific journals. You feel me? I like to sit, and listen to a lot of lectures from MIT professors and hear what they're saying about the world, and I decided to go with that. And what they say is everything is electric, the Earth is in the center, the Earth is not moving, and that middle one is ambiguous. The actual shape, it's ambiguous. That's why we went back and forth on that. So.
Okay, thank you. Interesting. Those observations of us being center of the universe apply to any point in the universe as well. That's what current observations show. Just before we finish up, I did find a video that I wanted to show of Mind Shock. Just for you, Ross. This is a video of Mind Shock.
That's him right there.
Yeah. This is direct footage of Mind Shock. There we go. Yeah, just so you're aware, that is actually main live footage directly of Mindshock. Okay, Icy Spin 199 says, Craig, can you confirm Ross bought evidence today? No, sorry. Sparky Steve, £5. Hey, genius, do you have Witsit's word salad bowl on weekdays and he has it on weekends like a divorced couple sharing a child? Grow up, Ross. Yeah, Witsit ain't smart. You should probably learn to know that. Icy Spin 199 says, hit that like for Craig, not me. If you haven't hit the like button yet, I'm going to send Daniel Pratt to your house. Icy Spin 199 says, sailors are often 100% surrounded by ocean. How? Yeah, amazing, that. Percy Fillington, $2. Love it when he tries to call out a logical fallacy. Yeah, well, to be fair, he thinks that Mindshock understands logic. Icy Spin 199 for both. What shape is Mars? Jessie, what shape is Mars?
Mars shaped. Sure looks spherical to me.
And Ross, what shape is Mars?
I don't know. Mars looks like it's just a light. So
I mean, it definitely looks spherical.
No, for sure.
I've looked at it through a telescope. It definitely looks spherical.
It's got a diameter. If you use a telescope, it's got a diameter. I looked.
Okay,
yeah, me
but
too.
We know light bends at far distances, so we don't know what the shape really is.
There's no refraction
train
in space.
Tracks touching in the distance? All right, we don't know.
Hey Ross, you know that train tracks touching in the distance is nothing to do with light bending, right?
It has everything to do with light bending. Yes, it does.
No, it really doesn't.
So how do train tracks appear to touch in the distance then?
Perspective.
What do you mean perspective?
Linear perspective.
Yeah.
Perspective of what?
Perspective. That doesn't even make sense as a question. Right, we're getting to this in our debate. Goodness me.
Oh no! It's perspective of light. That's why. Perspective of light.
Perspective of light. There's no such thing.
We're picking up the light. We're picking up the light that the object that is bouncing off the object.
Yeah, that argument really doesn't help you. Anyway, free run, $5. He thumbs down refraction so far. A 10-year-old can understand. He thumbs down refraction. 10-year-old so far. A 10-year-old can understand it, but Ross doesn't get it. Yeah. Free run for $5. Ross, stop saying it defies the laws of physics. You don't know or understand the laws of physics. Yeah, to be fair, Ross, you've said a few times that things defy the laws of physics, but my physics degree disagrees with you. But we can get into all that stuff.
Appeal to authority. That's appeal to authority. Who cares about your physics degree?
It's again, that's not an appeal to authority. Appeal to authority is appealing to an authority that is nothing to do with the thing that you are appealing to. For instance, if I said, for instance, Ross, I'm talking. Ross, I'm talking. All right, don't interrupt me when I'm talking. Okay. So an appeal to authority would be, for instance, if I said King Charles said the Earth is a unicorn. And because King Charles said it and he's an authority, we're going to go with that. That's an appeal to authority. If you say...
Charles said you're an expert in physics.
Again, Ross, hold on. So that is an appeal to authority. But saying, because I've got a physics degree, that is not an appeal to authority. They're different, okay?
Yes, it is.
Really need to understand logic. Zachary Burns member for you really don't. Zachary Burns member for 18 months says, I just realised voluntary listening to our Ross debate. We're in a bad place. Yeah, I apologise, guys. Icy Spin 199. Science is repeatable. Nod if you agree.
That one
Gary,
was good. That one was
Gary Little, $10. If the Earth is flat, then why does the U.S. Army teach its radio systems officers to use the horizon to provide separation between two radio transceivers? Ross.
They're lying. Actually, that was actually part of my exhibit. I just didn't get to it. But the Army, matter of fact, I have documents like our actual official Army documents that show that that in their math that they do not account for the curvature of the Earth whatsoever. This is a fact.
No,
document after document.
As ex-military with actual experience with documents and machinery, I can say that.
You're a liar. But thank you for your service.
No, I'm definitely not a liar.
No, come on, a prerequisite for being in the military is to be able to keep secrets.
I can show you all of the documents if you like. But anyway, Gary Little, $2 says, Ross has no idea how line of sight works with VHF. Yeah, Ross, could you define line of sight for us?
I did. Line of sight.
Yeah, define it.
Line of sight.
What does that mean?
Two people, line of sight.
And what does that mean?
That means your eyes, right?
are at a place where they can make a straight line.
So
two people, their eyes are at a place where they can make a straight line.
So line of sight has to have two people?
I'm using two people as an example. It could be line of sight of, I don't know, but if the rock is line of sight, then it has to be a straight line from your eye. You're not going to catch me up with this. And even if you do, who gives a fuck? It doesn't prove your point.
Hey, I
didn't know what line of sight was. That doesn't now mean that the earth is curved. Who gives a shit?
Hey, Ross, dude, it's just, you're using these words, and I just want to clarify that you understand what they mean. Navy Jet Fixer for $10 says, and is it possible that pigs fly? No. Flanker 420, $5. Ross, what's the scientific theory? Is it a guess or an explanation or observable facts? Scientific theory and theory colloquially are different. Yeah, we went through that. I defined scientific theory for you guys. Daniel Eklund for 56 says, if we know something from history, it is that ignorance and mass acceptance of falsehoods is dangerous. Keep it up, FTFE. P.S. Love the song. Thanks. I really appreciate the support, and the song is awesome. You're right. Barry F, $5. Ask him the difference between sidonic and sidereal rotation. Yeah. Do you know the difference between sidereal and like a solar day, Ross?
You mean like the actual number difference between the two?
What? No, just the actual definition. What is the difference between a sidereal day and a solar day?
You're talking about the stars moving versus the sun's moving. They have different paths slightly.
Well, no, it's. Do you know what the difference between the two is?
Solar and the sidereal rotation. One is the stars, one refers to the sun.
In what way do they refer to the sun and the stars? Do you know?
Everybody can go goddamn Google it if they want. All right, I am not goddamn Google. Go Google it if you really want.
Okay, I was just asking if you knew. That's all. Nearco, member for 12 months, says here's to a year's support. And
if they want to know.
Yeah, no. Again, this wasn't for them. I was just asking if you knew. So Nearco, member for 12 months, says here's to a year's support and many more to come. David Lee, 199, says, so he runs from the gyro to Aether. I know. Stringer News 1, for $2, all scientists agree that Ross is a dumbass. Yeah, we had a meeting. We checked.
They also agree that the Earth is not moving and the Earth is in the center. So we can all agree on
scientists definitely don't agree with that. That's for sure.
In the center. I'll accept that.
But scientists definitely don't. Scientists definitely don't say that. That's for sure.
This is going to be a quote party, boy.
Yeah. Erga T for $9.99 says, clowns, worse than Gene Techman and Witsit, ignoring and denying isn't an argument, doing research and reading books isn't appealing to authority. No, I know. Erga T, $4.99, have them explain the discovery of Neptune without gravity. That's always fucking hilarious. Erga T,
I personally don't think that Jessie would agree with that last comment. I think Jessie would say that reading books is appealing to authority.
No, he wouldn't.
I don't know, though. I don't want to put him on the spot.
No, because Jessie understands what appealing to authority is, so he wouldn't say that. Erga T199 says we have telescopes. IV is telescope size and lens. Not sure that's what in direct response to, but thank you. And another one for 199 says he used Euclidean and then said red herring. I know, that was funny. That's a short moment for sure.
What did I say? What did I say?
You said Euclidean and then went into a red herring. Don't worry, I'm going to make a short out of it so you can see.
What was the red herring?
Don't worry, I'll make a short and you can watch the short and then you'll understand. Stephen Jarvis for £5 says, Craig, no question, but say hello to Rachie50. She's one smart and nice lady. Oh, go on then. Ask Ross. Ross, why are you a plonker?
What is that Australian or is that British? I don't.
Plonker's probably both Australian and British, I'd say.
Oh, I'm glad you admit that you guys are the same thing. Moving on.
Well, Australian people are just like people from London, but like slower and, under heat stroke. Design Song 1, $5 says, Ross constantly goes from I don't know, tell me, to that doesn't make sense, tell me why, to let me tell you because I'm simple, over and over. Observational there, nice.
Very clever, guys.
Jonathan H, $5. Flat Earthers are so infuriating. Part of me wants to believe it's not possible for someone to be that dumb. Ross getting mad about facts is telling.
Mad about facts. I guarantee you won't come on my page when we're done and explain to me what facts I got mad about. I promise you won't come.
I mean, you did get a little bit angry about what a scientific theory was, to be fair, but
Well, it's not that I get angry, all right? Everybody, like, when I get excited, that's me getting excited, all right?
Okay, Satan.
And honestly, that's me combating your tactics. Because you do the same shit I do. You feel me? But it's just that I do it too.
I haven't done anything.
I'm not doing it. I'm just saying. I got to do my tactics back.
Okay, Satan for $5 says, thanks for the debate. Unrelated, but what base is that, Ross?
I'm sorry. Go one more time.
What base is that? It looks like an FE Wildcat.
Oh, that's not mine. Actually, that's not mine.
Oh, is it not?
I don't play any instruments right now. Yeah, I mean, I know how to play them, but I produce on computers now.
I'm a guitar teacher. Do you want lessons?
I mean, sure. I'll take some lessons. Yeah. I mean, I already kind of know how to play, but I never got over the calluses that I needed to develop on my hands because I'm a saxophone player and a piano player. That's easy compared to playing the guitar. So once I started strumming, it literally, I felt like knives were going through my fingers, and I could never get over that feeling. I don't know if you understand what I'm talking about.
I do. I just pushed through. Urger T 499. Please ask how eclipses work in their minds. Perspective and refraction isn't an answer. We can get into that in the next debate. Adam Lepine, member for 7 months, says, your go now, man. Go get him. Research Cube Earth became a new member. Welcome to Scrappers. Thank you very much. Navy Jet Fixer, $5. How does he think we do dead reckoning navigation if we cannot do angle measurements? Yeah, don't worry. I'm going to get into all that after.
That's a reification fallacy, buddy, because you're assuming the angle. So if there's no angle there,
that's not what reification means.
That is what it means.
No, it's not. That's amazing.
Dude, are you just gonna sit here and pretend like we're not smart enough to read definitions of words all day?
All right, can you tell me what a reification fallacy is then, please?
All right. Go ahead. Yeah, go ahead. Finish. I'll have it up for you in a second. Go ahead.
Well, do you know what a reification fallacy is? Because I do.
Yeah. You're basically making a point, right, based on things that haven't been proven yet.
No, that's not a reification fallacy.
That's what it means. Is that what it means?
It's literally not. Okay.
Literally.
Flanker 420 for $10 says, Ross, I am an astrophotographer. I have photos I took myself of planets, suns, galaxies, and nebula. Why do they match NASA? Why are the galaxies spirals? Try yourself and get a telescope. No authority needed.
The only thing you've proved is that you guys can all take the same pictures. They match NASA because you guys took the same picture, dummy. Why would you ask me that dumb question?
So you agree that they took the pictures of the nebulas and stuff. Right, cool. Thank you. Jonathan H, $5 says, Ross seems like the kind of guy that thinks the sun and all other stars are just big bonfires rather than what they actually are, nuclear furnaces. That's JM Truth you're talking about. David Lee, $4.99. Ross, Craig, will have you curled up on the floor in the fetal position, drowning in Flerf tears, begging for your mummy. That's the predictions of our debate, Ross. Fine Media, member for 28 months, says, I missed a lot of streams, but the evolution of flat earthers is pretty stagnant since the usual responses to evidence is still yelling and Ross, I'd suggest reading the comments in yesterday's debate. Mike Goatkiller, $1.99 says, I can't face any more Ross tonight, I'm off to bed.
You know what,
absolutely, I am appealing to consensus, is 100%. And thank you, Mike Goatkiller, for your first super chat. Icy Spin, $1.99, it's just a few more, guys. Says, in science, are you a beta if you accept correction? No, being corrected is very important in science. Austin Salmons, your third ever super chat for $2. Ross, we need a sick bass solo. He can't play bass, unfortunately. Urger T says, Ross, go to planetarium for fuck's sake. They're fun. I'd advise everyone go to planetariums.
I'm in a planetarium right now. Ha!
No, you're not. It's a Rubik's, $2 says, as a bassist, glad to know that isn't his bass. And Urger T, $4.99, there's other space agencies around the world that aren't NASA. US government isn't defense of flat Earth. Right, there we go. Sorry, what?
Do those other space agencies receive government funds at all?
Not from
receive government funds. They also come with regulations and mandates that makes you a government organization. That's why all schools for the most part are government organizations. So when you have a degree from a school, that just makes you a government employee, basically. One big authority.
Oh,
that authority is government. The number one liars of all time.
Again, that's not an appeal to authority. Right, anyway, 100%. Ross, you're welcome just to stay in this Zoom call, and then we'll have our debate in about 10 minutes, and I'm just going to have a drink and stuff.
I was going to ask for 10 minutes so I can go use the restroom and stuff.
And the last one, Yahoo Lagoon, $2, says, I was happy to see a modern day debate. What a treat. I'm going to be on there some more soon, so don't you worry. Jesse, thank you very much for coming. I appreciate it, buddy. No, you're muted.
I appreciate you too, Jesse. It was a pleasure, man. You know, for everybody that says that, I'm like, even though of course, I maybe went a little bit too far, sometimes and cut Jesse off. me and Jesse I would say we're pretty respectful. I am me all the time, but it was nothing like my debate with Craig yesterday. Nothing like because Jesse's not Craig.
Where you
Jesse's
interrupted all
gonna
the
sit there
time.
and listen and have a cordial conversation. You know what I mean? So I appreciate you big time, Jesse. You know what I mean, for allowing me to have a cordial conversation. I apologize for the time that I interrupted you. 100%.
All right. Yeah. Thank you very much, Jesse. You're welcome to just jump out now, and I'll end this stream, and you can watch the next one. Thanks for coming, bud. Well, just a few more super chats have just popped in. Erger T 199. Does he know what a private school is? MB $5. Ross is dumber than a chess playing pigeon and too thick to know it. Top left winner 2024. No, that's Mind Shock. And Jonathan H $2. We need a Professor Dave and Ross debate. You are fucking right. Right, guys.
Are you serious? I would make Professor Dave rage quit.
No,
he would literally
you wouldn't.
rage quit going against me. Are you?
No,
dude,
I wrote his debate against Dave Weiss. That was fucking amazing. Anyway, guys, yeah, I will see you soon. Stay here for the next debate with me and Ross. And remember, stupidity is not a right. Fight the flat Earth.
Fight the flat. 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 Fight the flat.
The Craig. Level.
Fight the flat. 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 Fight the flat.
No.
Fight the flat. Fight the flat. Fight the flat.
No.
Fight the flat.
No.
The Craig.
Fight
Level.